I will be using the integral test to find out is this series converge or diverge. So for integral test, assuming you don't have the graph of the function at all, I have a summation n from 1 to infinity arctangent over n squared plus 1. For integral test, you need to check three things. You need to make sure that the function is positive, continuous, and decreasing. Since the summation is from 1 to infinity, I will have the function to be positive, continuous, and decreasing when x is greater than or equal to 1. So regarding the graph of arctangent, this is not supposed to be something you bring, you put that in your notes. Let's say the test is open notes or a cheat sheet. It's not something you put on a cheat sheet. The graph of arctangent, trust me, this is something that you must memorize. The graph of arctangent when x is greater than 1, this piece is always positive. And also, x squared greater than 1, when x is greater than or equal to 1, you square a number, you add 1 to it, that is guaranteed positive. So we have a positive divided by positive, then the function is positive. And then continuous, the arctangent when x is greater than 1, there is no vertical asymptote, same as the x squared plus 1. So we can just check the positive and continuous. So this one we can check that right now. It's easy check, positive and continuous. And then what about decreasing? That one isn't that easy to check. You will have to use the quotient rule. So you have to find decreasing. So to check decreasing, you have to find the f prime of x. This one is quotient rule. This one is quotient rule. What is quotient rule? Quotient rule is you have one when you find the derivative of a function. So usually that is a rational function. You have a function over another function. Let's say you have function f over function g, then that is gf prime minus fg prime divided by g squared. And then what is the, okay, for quotient rule, I always immediately square the denominator, that is x squared plus 1 square. That is the denominator square. And then you have a gf prime. So gf prime minus fg prime. Gf prime, the derivative of arctangent. What's the derivative of arctangent? The derivative of arctangent is 1 over x squared plus 1. That's the derivative of arctangent. So gf prime, that will just cancel the g. So this is equals to 1, and then minus fg prime. F is arctangent, the derivative of the g is 2x. So we have a 2x arctangent x. How do you know that this is less than 0? First of all, the denominator is always positive. The denominator is always positive. The numerator, you have 1 minus 2 times a number and then times arctangent. So that is negative. 1 minus that when x is greater than or equal to 1. So when x is greater than or equal to 1, so this is for the arctangent, that is this is the graph of arctangent. Okay, this curve is the graph of arctangent. I am not saying that this is the graph of the whole function. For tangent, arctangent, when x is 1 or bigger, so 1 or bigger, so you only have a small piece of y value that is less than 1, and then other than that, when x is greater than 1, this is all positive. So you have 2 times an x value, and then multiply the arctangent, 1 minus that is negative. So this is something that you have to process in your mind for the integral test. Okay, so we have to say f is decreasing for x greater than or equal to 1, and then this is a check. So we check decreasing, we check positive, we check continuous, and then now you can apply the integral test. And then regarding the derivative, the decreasing stuff, this is something that you have to process in your mind. Usually when they ask you to apply the integral test, they are satisfied. But it is your responsibility to do the check. It's like you know your car is running every day in the morning, but it is your responsibility to do a check before you start driving. All right? Okay, let's do the integral test. That is equals to integral from 1 to infinity, and then arctangent, I will be start using x divided by x squared plus 1 and then dx. And then for your presentation, you are responsible to write the limit, and then you have limit of the whole integral and the dx. All right, and then this problem is a u substitution. I am going to let u equals to arctangent x, and then the derivative of arctangent is 1 over 1 plus x squared dx. Move that to the other side, 1 plus x squared du is equals to dx. And then we do a change of variable. Change of variable, I will put this right here, and then the x squared plus 1 will be cancelled. Okay, the next step, I have limit as b approaches to infinity. I will just not mention the upper and lower limit because they are in terms of x. We are doing du right now. I have a u divided by x squared plus 1. If you like, I can put the u in dark blue because we let u equals to that. And then the dx is now in this yellow, duplicate in this yellow. And then do you see a cancellation? That one is equals to limit as b approaches to infinity. I have integral u du, right? Simple. Integral u du. And then that is equals to 1/2 u squared. 1/2 u squared. And then I will put the x back to it. And then that is equals to 1/2 1 plus x squared. And then there is a square. So since the x is back, I can mention that this goes from 1 to b. Okay, I will just duplicate the limit. I know people usually don't write the limit, but that is part of the presentation. Part of the presentation. U square, I don't think that is right. The u square, no. That is not right. The u is supposed to be arctangent. Arctangent x. Okay, arctangent x. All right, let's do a plug-in. Plug in a b, plug in a 1. b is infinity. Okay, what happened when you plug in infinity? You have 1/2 arctangent infinity, and there is a square, minus 1/2 arctangent 1, and then there is a square. Arctangent infinity, see? You need to use the graph again, right? So for arctangent, so let me just duplicate this graph. So we will do a copy and then paste. For arctangent, as x goes to infinity, y approaches to pi over 2. So we have 1/2 pi over 2, the horizontal asymptote square, minus 1/2 arctangent of 1, that is a pi over 4, and then a square. Okay, what is that equal to? That is pi square divided by 8 minus pi square divided by 32. Let's get a common denominator. 32, that is a 4 pi square minus pi square. That is equals to 3 pi square over 32. What does that mean? What does that mean? Okay, that means this. I have this integral. I have this summation. So I'm going to copy and then paste. I have this summation. That means I have this series that is equals to this, the integral. Okay, then I will just move that. That is equals to integral. And then this summation and this integral is equals to 3 pi square over 32. And then this is a finite sum. That doesn't go to infinity. That is not undefined. So the sum is finite. So that means we say the series converges by the integral test. Okay, you can add that to the back, by the integral test. Okay, each problem is pretty long, then I will just do one problem in a video. How's that? So this is one problem. I will just do one problem in a video, and then I will just make another video for the next problem. All right, I will see you there.